This video is about photoelectron spectroscopy. So if you guys haven't watched the light and electromagnetic radiation video, do that first. Then come back and watch this one because we're going to talk about something that's mentioned in that prior video, and you're going to need to have the knowledge in order to understand what's going on here. So, photoelectron spectroscopy. In that light and EM radiation video, we talked about something called the photoelectric effect. And that's this idea that electrons can be ejected from a sample, a lot of times a metal, if it's above a certain frequency. And the cool thing is that we can use this in order to probe the electronic structure of the atom by looking at essentially what's the ionization energy. So the technique that we're talking about is shown over here. So there's a photon source, and there's our friend H nu. So there's a photon source, and get a better circle there. There you go. Okay, so the photon source, and it's going to shoot, a certain frequency of light at some sample, and then the sample, if it's above a certain frequency, the sample is going to eject an electron, and it's going to go through, I love this term here, the energy analyzer. So anyway, this probably has magnets in it because this is a charged particle, and so it can deflect the electrons as it's moving. And by the amount of deflection, the amount of field that's applied, you can get a measure of what the kinetic energy of the electron is. Okay, so the way that this works, let's lay some math on it. All right, so this H nu, okay, over here, that's the total energy, okay, that is given to the electron. So the photon, it hits the electron, and it's going to give the electron a certain amount of energy. And two things are going to happen. So when we look at this electron, so I'm going to write this down here. So here's our positive nucleus, and here's our electron right here. And this photon comes in, and the electron gets ejected out, okay? What's left behind is an ion, okay? And so we can call that the binding energy, right? The energy that's going to bind this electron to the nucleus. So I'm going to abbreviate this as Be for binding energy. Okay, the energy that electric potential energy that we were talking about, in a previous video. Now, the other thing though is that we'll have this binding energy, and then there'll probably be some left over. So the electron gets ejected. So some of this total energy in the photon is going to be used to ionize it to overcome this binding energy, and then the electron's going to have some kinetic energy. Okay, kinetic energy. Okay, and so what you can do is you can rearrange this a little bit, and you can say, okay, the binding energy of one of these ejected electrons would be the kinetic energy that the electron has. I'm sorry. Versus, all right, would be the total energy you put into it. So this is the energy of the photon that you put into it, minus the kinetic energy that the electron has. And so again, this energy analyzer, essentially what it's doing is it's measuring the kinetic energy of the electrons. And H nu, you know how much energy you put into it. So if you can find the kinetic energy, and you know what H nu is, the difference between those two is going to be the binding energy of this electron. And so what we can do is we can plot this binding energy. Okay, we can plot how many electrons, so we'll plot how many electrons in the atom have a number of bonding energies. Okay, or have, let me think of a better way to put this, guys. All right, so what we can do is we can say, all right, we can determine, let's just go ahead and say this. How many electrons have a specific binding energy? Have a specific binding energy, okay? And and looking back at the shell model, this can tell us something, right? Because if we have like a shell here, and then maybe we have, a couple electrons and a shell out here, we would expect these electrons to have a different bonding energy because they're further away from this nucleus, right? This will have a different bonding energy, a lower bonding energy than this electron right here, right? So maybe we have 2 electrons here, we have 2 electrons here. And what this photoelectron spectroscopy will allow us to see is how many electrons have certain bonding energies, okay? And what we get is a graph that looks like this. Now, notice some weird things. Notice some weird things about this graph. We're used to graphs starting at 0 over here and getting bigger. In a photoelectron spectrum, 0 is all the way out here. Okay, and it gets bigger over here. And then we have like these little breaks because we have a very wide range of energies. And so, we put these little lines to break it up because we can't have a uniform scale and have it still fit in this, nice little square here. All right, so these are the peaks we would get. And now the size of the peak, how tall this peak is, gives you an indication of the relative number of electrons. Okay, and so looking at this peak, it's about that high, right? And this peak, about that high. So to me, and normally there'd be like numbers, over here, right? But to me, it looks like this is 3 times taller. And if it's 3 times taller, that means that there's 3 times the number of electrons with this bonding energy than with this bonding energy. Okay, and so we look and we say, okay, well, we have some electrons out here at this low bonding energy. Then we have this, we have like 3 times the number of electrons at this bonding energy, and then we have another one that's pretty close to it, but it's not the same. And then we have one that's a very high bonding energy that's about the same height as these other 2. So we can reason that this peak and this peak and this peak have the same number of electrons. Let's go back. Sorry, it's weird. Oh my goodness. Oh my goodness. Okay, let's see if I can fix this real quick. I'll keep my annotations. Oh, I was about ready to make my final point. All right, so let me try this again, guys. Let me go back to right there. Okay, so I'll just make my point here. So we can conclude that this and this and this all have the same number of electrons. And what's really interesting is right here, okay? Because if in the shell model, we would expect to have like maybe one shell at low energy, another shell at some intermediate energy, and maybe a third shell right here, right? We can interpret it like that. But this shell in the middle seems to have 2 different energies in it, okay? And that's interesting, okay? It seems like the electrons in the shell have 2 different energies, slightly different from each other. And we will look at that more. So I'll just leave that as a cliffhanger, and we'll look at that more in class.